Imagine this, you're playing Minecraft on your computer, then later checking your bank account at an ATM, and later scrolling through an Android app on your phone. What if I told you that all of these games, banking systems, and apps have something in common? That something is called Java. Java is one of the most popular programming languages in the world. And it's powerful because of one magical idea: write once, run anywhere. That means a program written in Java can run on different devices, computers, phones, or even smart appliances without being rewritten. And don't worry, I'll make sure we have fun with the examples and quick challenges along the way. I am Kili Mirona Laksamana, a QCian at Quezon City University. As a Bachelor in Science and Information Systems student, I will show you what Java really is like. Now, let us check our learning outcomes. Describe and discuss Java story, technology, features, and requirements. Differentiate applets and application. Let us now dive deeper into the origin of Java. Once upon a time, in 1991, a group of engineers at Sun Microsystems had a big dream. Led by James Gosling, they wanted to build a programming language that could work anywhere, whether on a computer, a television, or even a small and electronic device. James Gosling and his team started a secret project called the Green Project. They wanted a language for consumer electronic devices like TVs, microwaves, and set-top boxes. The very first name was GreenTop, and the files had a GT extension. Soon they renamed it to Oak after the oak tree was outside Gosling's office. They also called a project called Start 7 that was an early prototype device built as part of the Sun Microsystems Green Project, and it played a key role in the genesis of Java. But when they tried to make it official, they discovered Oak was already trademarked by a computer company. So after brainstorming names like Silk, DNA, and Pepper, they finally landed on Java, inspired the coffee from Java Indonesia. In 1995, Java was officially launched, carrying its famous slogan, "Write once, run anywhere." Time magazine also called Java as one of the 10 best products of 1995. On January 23, 1996, they released JDK, or Java Development Kit 1.0. This was the very first official version of Java, and it included all the basic tools developers needed to write, compile, and run Java programs. With JDK 1.0, programmers could finally try out this new language that promised their motto, "Write once and run anywhere." It came with a small set of core libraries, the JVM or Java Virtual Machine, like the engine that makes Java run. And that release was the spark. Java spread rapidly, first with applets running inside web browsers, and then with enterprise systems, mobile apps, and beyond. The latest, Java 21 in 2023, that has the latest superpower, or LTS, that has a virtual threads and super lightweight threads for concurrency and enhanced pattern matching and record classes. Today, Java is not just about desktop or enterprise apps, it's everywhere. Well, Java technology is more than just a language. It's a platform that provides everything you need to create, run, deploy applications. Java technology can be understood in four ways. One is a programming language, development environment, an application environment, and a deployment environment. When we say Java is a programming language, it isn't just another language. It came with powerful features that made it different from C, C++, and others. Here's what makes Java special. It is simple. It's designed to be easy to learn. Java removed complicated concepts from C++ like pointers and operator overloading, so beginners can pick it up quickly. When we say Java is object-oriented, that means Java uses real-world concepts. Everything is treated as an object with attributes and behaviors. This makes programs modular, reusable, and easier to maintain. We have the 6 pillars: object, class, encapsulation, inheritance, polymorphism, and abstraction. Object is something that represents a real-world thing. It has properties like data and behaviors like actions. For example, A dog object has properties like color and breed, and behaviors like bark and eat. While class is like a blueprint or a template used to create objects. For instance, the car class defines what all cars have in common, such as wheels, colors, and speed. Actual cars like Toyota or Honda are objects created from that class. Encapsulations means wrapping data or the variable and methods like functions together into a single unit and restricting direct access to some parts of it. For example, think of a capsule medicine. The medicine is hidden and you only interact with the capsule as a whole. In Java, we use private variables and getter or setter methods. Java keeps data safe by allowing controlled access through methods. Second is inheritance. Inheritance in Java is a mechanism where one class or subclass acquires the properties and behaviors of another class, parent or superclass. Inheritance let us reuse code, create hierarchies, and make programs easier to maintain. Next is polymorphism. It means the same method can behave differently depending on the object that calls it. A good example is the word run. A person can run, a program can run, and even water can run. Same word, but many different meanings or behaviors. That's exactly how polymorphism works in Java. Lastly, we have abstraction. Abstraction is all about showing only the essential features and hiding unnecessary details. It is about designing a system by focusing on what it does and not how it does it. It's like when you drive a car. Use the steering wheel and pedals. You don't need to know how the engine works inside. When we say Java is secured, Java provides a secure environment for running code. It has a built-in security features that prevent harmful code from accessing files or stealing data. For instance, an applet downloaded from a web browser or website is restricted, so it cannot delete anything from your own computer. Another powerful feature of Java is that it is platform independent, which means write once, run anywhere. Instead, when you compile Java code, it becomes bytecode, and this bytecode is run by the Java Virtual Machine or JVM. Since every system has its own JVM, the same Java program can run anywhere. This means that if you write a program on Windows, it can also run on Linux or Macs without rewriting the code. Java is also considered robust because it has strong error handling features and strict type checking. If you make a mistake, Java can catch it before the program crashes. For example, dividing a number by zero in Java will not crash the entire system, but will throw an error message called arithmetic exception. Another thing is Java is portable, which means the same code can run on different systems without changes. For example, you can save a Java-based calculator program on a USB drive, and it can run on any computer with Java installed. Architecture neutral, it means it does not depend on a specific type of hardware or processor. Unlike assembly language, which only works on one type of CPU, Java can run on Intel, AMD, or ARM processors. Java is dynamic because it can load new classes at runtime. Java is interpreted because its bytecode is executed by the JVM. It is also high performance, since it uses just-in-time compiler to make programs run faster. Java is multi-threaded, which means it can perform multiple tasks at the same time. For example, a music player written in Java can play one song while downloading another in the background. Java is distributed, which means it can run across networks. This is why Java is used in online banking systems, cloud computing, and even streaming services like Netflix. When we talk about building and running Java programs, the most important tool you need is the JDK, which stands for Java Development Kit. The JDK is a software package provided by Oracle and other vendors that contains everything a programmer needs to develop, compile, and run Java applications. Without JDK, you cannot write or test Java programs because it provides the essential tools and libraries. Now we have the program cycle. The Java program cycle has three steps. First, you write your code and save it as a .java file. Second, you compile it using Javac. This creates a .class file which contains the bytecode. And finally, you run the program using Java. Now that we know how Java programs are created and executed, let's compare the two types of Java programs, applets and applications. Now, an applet is a small Java program that runs inside a web browser. Now, back in the early days of the internet, applets were often used for interactive calculators, games, or animations. Like these types of games like YA, Frib, and so on and so forth, our childhood games. On the other hand, an application is a standalone program that runs directly on your operating system without a browser. For example, the famous game Minecraft was originally written in Java, and many desktop applications, such as IDEs like Eclipse and IntelliJ, are Java based. Now that we understand the types of Java programs, let's talk about their structure. So for our first structure, we have a class. A class is a Java blueprint or template that we use to create objects. It contains variables, data, and methods like behaviors that define how objects will look and act. Example would be a car class that can have variables like color and speed, and the methods like drive and brake. Object is an instance of a class. It is the actual thing created from the blueprint. Each object has its own values, the variables defined in the class. Example from the car class. You can create objects like Toyota or Honda. Tree is a method. A method is a block of code inside a class that performs a specific task. It can like an action or behavior of the class. Example would be drive, eat, or bark. It can be methods. So in every Java program, there must be a special method called main, where the execution starts. So main, which is the method, is the entry point of every Java program. When you run a program, the JVM looks for public static void main string of arguments and starts execution from there. Example would be public static void main string arguments, then system.out.print and line hello Java. So we have also the statement. The statement is a single instruction that tells the computer to do something. Statements are written inside methods. An example here would be the system.out.print line quote hello Java. This is a statement that displays text on a screen. Now we have the comments. Comments are notes written in the code that explain what the program does. They are ignored by the compiler and are only for the programmer. An example would be is the double forward slash. This is a single line comment, and it could be also the asterisk then forward slash. Then this is a multi-line comment. In summary, we learned Java started as GreenTalk, then became Oak, and was finally renamed Java after the famous coffee from Indonesia. We also explored its version history, its role as a programming language and technology, and its powerful features such as being object-oriented, secure, portable, and platform-independent. We studied Java development environment, the program cycle, the difference between applets and applications, and the structure of a Java program. Java is not just a language. It's a complete platform that powers banking systems, Android apps, cloud computing, and even streaming services like Netflix. Its ability to be simple, robust, and portable makes it one of the most important programming languages in the modern world. Now, I hope you learned a lot in this video. Once again, I am Kilin Yona Laksamana. Remember, every great programmer starts with small steps, and the tools is one of the most important first steps. That's all for now, and I look forward to continuing our journey into Java programming together. Until next time, keep practicing, keep learning, and most importantly, enjoy coding. Bye-bye!